Hello, my name is Martin Eisenberg. I represent OSGeo and also myself as rapidlasso GmbH. Um, I'm here at the Point Cloud meeting in Dublin in June 2016 to give an update on the work for the native extension of LASzip to compress the LAS 1.4 point types. The original reason I'm here was the desire to avoid a fragmentation of the compressed formats for storing the LAS point clouds. I just like to remind you of that. Okay, so the standard we all know is simply ASCII. X, Y, Z, sometimes intensities. Those were the first ways the points were stored. And those file formats were good enough until we started storing millions and billions of points in them. Due to the foresight of a few people in the industry, we have a wonderful format. And when I say we, I mean the airborne LiDAR scanning and the mobile LiDAR scanning communities. To a certain degree, now also the dense matching communities are storing the output of the photogrammetric point clouds in the LAS format, as it also serves their needs quite well, and it's very widely supported. It is a very simple format. It has a simple header, and then depending on the point type you choose, you just have the same record, commonly the 28-byte record, point data format 1, repeated again and again and again. That's the file. It's very simple to write a parser, a reader, and a writer. The nice thing about this is the coordinates have uniform resolution. That means every point gets the same number of digits after the decimal point. You write down integer coordinates, and well, how do you get the digits? Well, you have to go to the LAS header. In the header, we have a scale factor. And let's say you want centimeter resolution for your points, because that's what the scanning error tells you, which is what we commonly use in airborne data, then you would use an 0.00 scale factor. So every number gets multiplied by 0.00. And in order to keep the integer small, you don't want to work with numbers that are far shifted away, like the typical UTM projection or other kind of projection. So we have an offset that we also add to the number, which gets us to the final location. And this combination of scale and offset allows us to use integers for the coordinates, and those in turn allow for very efficient and for lossless compression. And that's really why I wrote initially as an academic paper LASzip in I think in 2005 or 2006 I started with that. And it turned out to be very successful, and it turned into literally a de facto standard that everybody is using today who has large amounts of airborne LiDAR data. And yeah, I've been a bit overwhelmed myself how successful this initial academic project has become. The reason for its success is most likely the licensing. It's open source and LGPL, meaning everybody can integrate it without any costs into their open source or commercial solutions. If you want to know more, there is a YouTube video on this paper. Compression is not everything. Some people want to fast access to particular regions of among large amounts of LiDAR. This requires some form of spatial indexing approach. To accompany the LAZ compression scheme, there is something that I called LASindex, which creates the LAX files, which can optionally also be inside the LAZ file, which does spatial indexing. That's not what I want to talk about. If you're interested, again, there is a YouTube video on that. So LAZ has been immensely successful, and a lot of software, including most of my competitors, are supporting this format now. And that's great, because exchange of open data is wonderful. That's why we're here in the Open Geospatial Consortium. So how does this LASzip work? In a previous OGC meeting, I talked about it. So it writes the header just like it is, and then it groups points in chunks. This chunk size is by default 50,000 points, but you can change it. And then it writes the first point just as it would be written in an uncompressed file, and all the following points of every chunk are now incremental changes to that first point. And then by clever modeling of the likelihoods and compressing it with arithmetic coding, we get small files. This predictive coding works well because, well, here's an example. We have a prediction and we have the real coordinate. Once we have that, all we need to store is a correction. And the correction tends to be not only just a smaller number, but if I look at the distribution, here's the original coordinate distribution, and here's the corrected distribution, I get a very, very tight distribution. Why is this good? Well, if you know anything about entropy coding, if you have a sequence of symbols, if the symbols look like this, meaning there's one of many and the others are not so often, you can store it with much fewer bits than if they are all of the same probability. And that's the whole secret of compression. The results are quite good. LASzip is unrivaled still among the best compression schemes out there for lossless storage of points. Lossless storage without reordering, I should also mention that. And if you want to know more details, you can also read the paper that was published in the ASPRS journal in 2013. Okay, but here comes LAS 1.4. What's the big change? Well, there are a lot of smaller changes, but the big change, the change that really requires a new compression scheme, is the new basic point type that will also be used by a lot of federal agencies now in the US. So this is the old point type still, the point type 1, which is now what's been used in the past. So let's see what the changes are. Well, first of all, there are a lot of things that don't change. The coordinates are still treated the same intensities, the point source IDs, the GPS times, all that stays the same. What changes is the return counts and the return numbering gets an extra bit. So instead of only discriminating 7 different returns, we can now discriminate up to 15. That has become necessary with the new sensors that produce many more echoes per shot. The other thing, classification and flags will occupy more bits. There are more classification codes now supported in the official numbering of classification codes, and we have an additional classification flag, the so-called overage or overlap flag. Finally, the scan angle has become a bit more precise. Instead of storing only the degree, we now store the degree in increments of 0.06 degrees. And finally, we have an entirely new field that's only 2 bits. And that encodes 1 of 4 possible scanner channels, since the scanning systems we now have often have more than 1 beam shooting at the same time. So that means that instead of 28 bytes, our new core point type has 30 bytes. And that requires a completely new compression scheme that is fundamentally very similar. You know, it wouldn't require very much to modify the current one, but it will be incompatible. So to make it compatible, there was a quick hack that we did, I think already 2 years ago now. That allows the new content to be stored, compressed, by first downgrading it to old content. That has the advantage that all existing software can readily read it, and all old software won't be able to use those new things anyways, because it's old software. However, we also eventually want a native extension. And the idea was not to rush it. Extending what we have would be quick. I mean, there's not a huge change happening. You just saw the few little changes that happened. The idea was to think about it for a long time and not just make a quick extension and then think a year later, had we only done this and this. So I made an open call and been collecting ideas ever since. Was looking for sponsors to come up with a prototype. The idea is to exploit that break in the format. Let's keep what works. Let's improve where we already have some good ideas, where we need to improve, and let's look what other people would like in the format and add that as well, so they can use that format as well. So please tell us your needs. So the new point types, these are point types 6 to 10, they're not only a problem, well, they are a problem because everybody will need to update their software in order to once to read just the new point types and again to read the compressed new point types. But this, for the compressor, this also provides an opportunity. We now can improve things in the compressor because we now make a new compressor. And two things I would really like to talk about that are right now being implemented. Selective decompression and variable chunking. These will, when we roll out and nobody cries, oh, don't stop, do something else, I have a better idea. Those will be the two big new things when we roll out LASzip for 1.4. First of all, the file layout for the LAZ files will be very similar. The header, the VLRs, those will not be compressed, and then the sequence of chunks. At the end there's a chunk table that tells me where the chunk is that I might be interested in for random seeks. And the new things, the chunks are layered and the chunks can have a variable size. Those are the new features in LAS 1.4 compression with LASzip. Why compress chunks and layers? Well, I write a lot of LAS tools, and many of my tools don't need all the information in the point. Often I only need the coordinates. Like if I compute the bounding box, the bounding box of the coordinates, then all I need to decompress is x, y, z. So the idea is to layer together things that are very likely to be needed for sure and make everything else optional, so it does not need to be decompressed unless you really need it, because compression takes time. Currently my best guess is to group that together as a core layer. The coordinates, the return numbers, the scanner channel we need for better compression, and the point source ID as well. All these things are very much correlated. That would be the base layer. On top of, then you could also want to ask, I want also the classifications. So I want to be able to tell what is the ground point, what is the building point, and the classification flags. One could argue this should also go into the base layer, and I could potentially be convinced, and we will run some experiments, how much that actually is, and if it's worthwhile to have that as a separate layer or not. So that may still change, and your input may help change that. However, the other things are very likely to remain in other layers. The intensity, the user data, the scan angle, and the GPS times. The intensity I really only need when I rasterize an intensity raster in my particular applications. The user data I hardly ever need. The scan angle I only need when I compute overlaps, and the GPS time I mainly need for sorting the points. So a lot of decompression time will be eliminated by not decompressing those parts of the file that we are not interested in by a particular application. The other thing was variable chunk sizes. And why would you want variable chunk sizes? Well, Howard Butler really wants them, and I should be using them too sometimes. A very typical use case is when you create a spatial indexing, either using a quad tree like you see here or an octree. Then what you end up, you have cells, and each cell has a different number of points. And ideally, you want now to store the file with the granularity of single cells. So you can say, give me the points of this cell and give me the points of this cell. Now a fixed chunking isn't compatible with that sizes of these cells, so you end up always decompressing more that covers like more than your cell. So that's an inefficiency. So chunking, variable size chunking, will allow you to say, oh, now start a chunk, and then now end a chunk. And that can be 100,000 points, it can be 70,000 points, it can be 20,000 points, depending on the size of your cell. So those are the two features. I hope you can see that web address up there. It's a GitHub LASzip. That's a document I'm trying to maintain that also is a specification of that new native compression for LAS 1.4. A big disadvantage right now is that there is no real specification document. The specification is mainly the implementation and the paper that I mentioned before. So now from the start, I'd like to develop the code and the specification document in an interwoven manner. And if you want to look at the current state and comment on it, please do so.